Alright, let's talk about acceleration. So acceleration is the change in velocity over a change in time. And since velocity is a vector and acceleration is related to a velocity, that means that the acceleration is a vector also. So it can be positive or negative. That's its direction. It can be moving in a positive direction or negative direction. Okay, so here's our equation for average acceleration. Remember, we could write it with that bar over the top of it. And it's the change in velocity, or delta v, over delta t. So final minus initial for both of those. The units, remember, velocity's unit is meters per second, time's unit is seconds. So we've got meters per second, alright? And we can go ahead and write this second here, since it's in the denominator. It's like saying 1 over second. So meters per second times 1 over second gives us meters per second squared. Remember, or notice, I should say, that this equation up here is just like the slope formula again, like we had from our position versus time for the average velocity. Alright, so that means that if you were to graph velocity and time, the slope of the line that's created would be the acceleration. And if you find the area under the line, that's going to be equal to the displacement, alright, or how much the object moved. And I'll show that to you in a graph in just a second. Alright, so we have a velocity versus time graph here. And let's go ahead and talk about the velocities first. Alright, we're going to start at 0 here at the origin. And take a look at this velocity. Alright, what can you tell me about the velocity along that line? Okay, good, it's changing. Alright, we have here at this position, we have one velocity. And let's say we did this one here, we have a different velocity. So our velocity is changing all the way along this line. Alright? And the velocity here, what is it? Hopefully you did not say 0. Hopefully you said that it was 5 meters per second. Remember, this is a velocity versus time graph, so you can actually literally just read the velocities off of this graph along the way. So right here the velocity is 4 meters per second, and right here it's 3 and 2 and 1. So looks like at, is that right on it or not? Little less than 1 second, the object was going at 2 meters per second. When we look at the slope of these lines, we're looking at the acceleration. Alright? So, right here, what can you tell me about the acceleration? Okay, hopefully you said that the acceleration is equal to 0 here. The reason for that is because the velocity doesn't change. Remember the formula we just saw, the acceleration is the change in velocity over the change in time. So if you look at these points here, the final velocity here is 5 meters per second, and the initial velocity is 5 meters per second, and that's happening, I don't know how exact my lines are, but we can say 4 seconds minus 2 seconds. So 5 minus 5, 0, over 4 minus 2, 2, and all together that still gives us 0. So the acceleration on that line, or in this range of time here, is 0, which means this acceleration here is 0 as well. Alright? And so what else can you say about the acceleration? And tell me about the acceleration for the whole graph. What can you say about all the accelerations? Right? Hopefully you said that all the accelerations were constant, and you'd be right. The reason for that is because they are all linear. Alright? They aren't speeding up or slowing down. They are constant throughout this entire graph. Okay, so let's take a look at what I talked about. The displacement was the area under the line. Alright, if you want to know how far the object traveled between 2 seconds and 4 seconds, then we have to find the area underneath the line in our velocity versus time graph. Okay, notice the units. We have meters per second on this axis and seconds on this axis. And let's take a look at the area of a rectangle is going to be the base times the height. Well, the base would be in units of meters per second times, the base would be in units of seconds, and the height would be in units of meters per second. Alright, now this seconds is the same thing as seconds over 1. So this one on top cancels with that one on bottom, and you're left with meters, which is the unit for displacement. Alright, so that shows us that the area under the curve here, and even though it's a straight line, it's really called a curve, is going to be our displacement. And that's true on a velocity versus time graph. Okay, so why don't we go ahead and figure that out and see how far the object did travel between 2 and 4 seconds. Alright, so all we have to do is figure out what this is. Alright, that's going to be 2. And now let's figure out what this value is. Alright, we've got 5 minus 0, so this is 5. Alright, so our displacement then is going to be 5 times 2, which equals 10. So whatever object this is traveled 10 meters in that space right there. It did not accelerate while it was moving, but it was moving. Just because its acceleration is 0 doesn't mean that the object wasn't moving. It just means it wasn't getting faster and faster or slower. Alright? And again, what was the velocity of the object while it was moving that 10 meters with 0 acceleration? It was 5 meters per second. Okay? Let's figure out what the acceleration is along this line using our new equation for average acceleration. Alright, so we're going to say that this is our final position and this is our final velocity and this one's our initial velocity. So the final velocity was 5 meters per second, the initial was 0 meters per second. Okay, and now our time, I'm going to go ahead and say that that's 2. So we've got 2 seconds minus 0 seconds. So the acceleration then is going to be 5 meters per second divided by 2 seconds. So we get 2.5 meters per second squared as our acceleration of the object along that line. Okay, I'd like to know now what the displacement of the object was up to 2 seconds. So from 0 up to 2 seconds, I want to know how far it moved. Alright, so here we have a triangle, so we're going to say that the displacement is going to be equal to the area of a triangle, which is equal to 1/2 the base times the height. Alright, so our base is time and our height is velocity. Alright, so the displacement then is going to be equal to 1/2 times 2 seconds for the base times 5 meters per second for the height. Alright, so let's just say here 1/2 times 2 is 1 times 5 meters per second, so we get, and then these seconds here cancel out, and so we get 5 meters. So the object traveled 5 meters, alright, and that was at a constant acceleration of 2.5 meters per second the whole time. And it had different velocities along the way, alright, which is indicative of this acceleration. That means it's speeding up. In order for the acceleration to have a positive slope, that means that the velocity must be increasing more and more with every passing second. Okay? I want you to go ahead and figure out what the acceleration is at letters C, D, and E. So you're going to need a minute to do that, so go ahead and pause the video, figure that out, and then start it back up again to see the answers. Okay, so here's the answers to this graph. We have an acceleration of negative 2 meters per second here. Notice that's your initial velocity, that's your final velocity. The acceleration has a downward slope, so you knew it was going to be negative just based off of that. And if we look at our times, we got like what, 4 and 5, so that would be 3 minus 5 over 5 minus 4. So 3 minus 5 is negative 2, 5 minus 4 is 1, so that's where we get our negative 2 meters per second squared. Alright, this one is a horizontal line, just like this one is. That means the acceleration is 0, because the velocity is not changing. And then here you could pick these points, and you're going to get 7 meters per second minus 3 meters per second over, oh, my apologies, not 7. You're going to get 0 meters per second minus 3 meters per second over 7 minus 6. So 0 minus 3 is negative 3, and 7 minus 6 is 1, so again we get negative 3 meters per second squared. Again, negative because that's a downward sloping line. Okay, I think that is all for this time. Thank you for learning with me, and I'll see you next time.